one can never be die. Hi guys, yes, it is true. You will never believe this truth. Without fighting with the death, one can be immortal. The figure is here. The reality of the radioactive affected two Nobel Prize winner, Madame Marie Curie. She never cared with the hunger, illness and death, and continued her research with a great passion. Her body decayed and dissolved in the universe. Her soul and work are still there. There are thousands of shelves, out of which there is one shelf in Bibliothèque National Library in France, in which there is one lead-lined box. In that box, books of theories which Madame Marie Curie invented, the elements polonium and radium, have been kept. One cannot read those books without wearing radioactive suits and masks, because the books have been contaminated with the most dangerous elements on the earth, polonium and radium. First, these radioactive elements, polonium and radium, she invented has to be deactivated by its own for next 1500 years. Then you can see it with your naked eyes and skin. So burning issue, you don't have the ability to touch it freely. One can't grab the burning sun. Like that, her work. 1925 was awarded the then unprecedented second Nobel Prize 100 years ago when Marie Curie came to the United States for the first time in May 1921. She had already discovered the elements radium and polonium, coined the term radioactive, and won the Nobel Prize twice. But the Polish-born scientist, almost pathologically shy and accustomed to spending most of her time in her Paris laboratory, was stunned by the fanfare that greeted her. She attended a luncheon on her first day at the house of Mrs. Andrew Carnegie, before reception at the Waldorf Astoria and Carnegie Hall. She would later appear at the American Museum of National History, where an exhibit commemorated her discovery of radium. The American Chemical Society, the New York Mineralogical Club, cancer research facilities, and the Bureau of Mines held events in her honor. Later that week, 2,000 Smith College students sang Curie's praises in a choral concert before bestowing her with an honorary degree. Dozens more colleges and universities, including Yale, Wellesley, and the University of Chicago, conferred honors of her. The marquee event of her 6-week US tour was held in the East Room of the White House. President Warren Harding spoke at length, praising her great attainments in the realm of science and intellect, and saying she represented the best in womanhood. We lay at your feet the testimony of that love which all the generations of men have been owned to bestow upon the noble woman, the unselfish wife, the devoted mother. It was rather odd thing to say to the most decorated scientist of that era. But then again, Marie Curie was never easy to understand or categorize. That was because she was a pioneer, an outlier, unique for the newness and immensity of her achievements. But it was also because of her sex. Curie worked during a great age of innovation, but proper women of her time were thought to be too sentimental to perform objective science. She would forever be considered a bit strange, not just a great scientist, but a great woman scientist. You would not expect the President of the United States to praise one of Curie's mates to his manhood and his devotion as a father. Professional science until fairly recently was a man's world, and in Curie's time it was rare for a woman even to participate in academic physics. Never mind triumph over it. The United Nations named 2011 the International Year of Chemistry. Curie has always been a fascinating character, the subject of books and plays and movies, and the anniversary has prompted several new books about her. October is Nobel Prize season, so it is a good time to examine how she lived, but also how she has been mythologized and misunderstood. Curie was born Ania, Slovakia in November 1867 in Warsaw, Poland, and raised there during a Russian occupation. Her mother died of tuberculosis when Marie was 10 years old. To avoid narrow-minded people who were harassing her, a prodigy in both literature and math, as a teenager, Marie attended a secret school called the Floating University. Its local changed regularly to avoid detection by the Russians, which taught physics and natural history as well as the forbidden subjects of Polish history and culture. Her father, a science teacher, encouraged his daughter's curiosity but could not afford to send her to college. Marie worked as a governess until, at 24, she had saved enough money and purchased a train ticket to Paris, where she gravitated to the Latin Quarter and enrolled at the Sorbonne. She immersed herself in French and math and made ends meet cleaning glassware in university labs. She rationed her intake of food until, on more than one occasion, she collapsed of weaknesses. Science thrilled her, and she earned a degree in physics in 1893 and another in mathematics the following year. In 1894, she met Marie Curie, a 35-year-old physicist at a French technical college who had been studying crystals and magnetism. More than a decade before, he and his brother Jacques had discovered piezoelectricity, the electric charge produced in solid materials under pressure. Perry was taken by Marie's uncommon intellect and drive, and he proposed to her. It would be a beautiful thing, he wrote, to pass through life together hypnotized in our dreams. Your dream for your country, our dream for humanity, our dream for science. They were married in 1895 in a civil service attended by family and a few friends. For the occasion, Marie donned a blue cotton dress, one practical enough to wear in the laboratory after the ceremony. From then on, she and Perry followed what they called an antenatal path that included a renunciation of the pleasures of life. They lived plainly in their apartment within walking distance of their experiments. Perry earned a modest 6,000 francs per year, about $30,000 today, while Marie worked gratis in his laboratory and prepared for an exam that would certify her to teach girls. The Curie's first daughter, Irene, was born in 1897. A difficult pregnancy had forced Marie to spend less time in the lab, just as she was gathering data for the doctoral thesis. When her mother-in-law died weeks after Irene's birth, her father-in-law, Eugene, a retired physician, stepped in, becoming the hands-on parent that others expected Marie to be. By the time her second daughter, Eve, was born in 1904, Marie had grown accustomed to the distance of colleagues who thought she spent too much time in the lab and not enough in the nursery. Georges Sagnac, a friend and collaborator, eventually confronted her. "Don't you love Irene?" he asked. "It seems to me that I wouldn't prefer the idea of reading a paper by Rutherford to getting what my body needs and looking after such an agreeable little girl." But read scientific publications she did. In labs across Europe, scientists were studying new and surprising phenomena. In 1895, Wilhelm Röntgen had discovered X-rays, and the mathematician Henry Poincare sought to understand the luminescent rays that could pass through a hand and impress a ghostly image on photographic paper. Henry Becquerel was noting the emissions of different kinds of mysterious rays, those from uranium salts. J.J. Thomson discovered negatively charged particles, which we now know as electrons, and which we now know are the source of X-rays. Curie built on Becquerel's observations of the element uranium. At first, she and other scientists were baffled about the source of the high energy emissions. The uranium shows no appreciable change of state, no visible chemical transformation. It remains, in appearance at least, the same as ever. The source of the energy it discharges remains undetectable, she wrote in 1900. She wondered whether the emitted rays were violating a basic law of thermodynamics, the conservation of energy. Finally, she posited a daring hypothesis. The rays emitted might do a basic property of uranium atoms, which we now know to be subatomic particles released as the atoms decay. Her theory had radical implications. Trish Besden, a senior chemist at the Lawrence Livermore National Laboratory, describes it as a shocking proposal. It was truly amazing and a bold statement at the time, because the atom was thought to be the almost elementary particle, one that could not be divided. It further meant that atoms are not necessarily stable. Curie's hypothesis would revise the scientific understanding of matter at its most elemental level. Curie set out to measure the intensity of uranium's rays by adapting the electrometer Perry had invented with his brother. The device allowed her to measure extremely low electrical currents in air near mineral samples that contained uranium. She soon repeated the experiments with thorium, which behaved in similar ways. But she was puzzled by data that showed that the intensity of the radiation emitted by uranium and thorium was greater than expected based on the amounts of the elements she knew to be in her samples. There must be, I thought, some unknown substance very active in these minerals, she concluded. My husband agreed with me, and I urged that we research at once for this hypothetical substance, thinking that with joint efforts a result would be quickly obtained. In 1898, she indeed identified one of the substances and named it polonium after her homeland. 5 months later, she identified a second element which the world came to know as radium. Curie described the elements she studied as radioactive. Along with her husband, she coined the term radioactivity. Radioactivity or radioactive decay is a property possessed by some elements or isotopes of spontaneously emitting energetic particles, nuclei. During radioactivity, an unstable nucleus decomposes into a stable configuration by emitting certain particles such as electrons or alpha particles, certain forms of electromagnetic energy. Radioactivity is produced by radioactive elements such as uranium, thorium, polonium, and radium. Radioactivity was discovered in 1896 by the French scientist Henri Becquerel, who found that uranium emitted radiation. Marie Curie and her husband Perry conducted further research in this area to find electricity conducting elements which showed properties similar to that of uranium. During the course of this research, it was the Curies who first described this phenomenon using the term radioactivity, which is based on the Latin word ray. Marie and Marie Curie's study of radioactivity went on to become an important factor in the science and medicine. Perry put his crystals aside to help his wife isolate those radioactive elements and study their properties. Marie expected pure radium salts from pitchblende, a highly radioactive ore obtained from mines in Bohemia. The extraction required tons of substance, which she dissolved in cauldrons of acid before obtaining barium sulfate and other alkalines, which she then purified and converted into chlorides. The separation of radium from alkalines required thousands of tedious crystallizations. But as she wrote to her brother in 1894, one never notices what has been done. One can only see what remains to be done. After 4 years, Curie had accumulated barely enough pure radium to fill a thimble. Working in a dilapidated shed with broken windows and poor ventilation, she nevertheless was able to make sensitive measurements. It is remarkable, says Bisden, that Curie calculated the atomic weight of radium so accurately given such deplorable conditions. Large swing in temperature and humidity undoubtedly affected the electrometer. But Mary's patience and tenacity prevailed. Both Curies were plagued by ailments, burns and fatigue that, in respect, were clearly caused by repeated exposures to high doses of radiation. Both, too, were resistant to the suggestion that their research materials caused their ailments. In 1903, Curie became the first woman in France to earn a PhD in physics. Professors who reviewed her doctoral thesis, which was about radiation, declared that it was the greatest single contribution to science ever written. Rumors of a Nobel Prize began to circulate, but some members of the French Academy of Sciences attributed the brilliance of the work not to Mary, but to her co-workers. These skeptics began to lobby quietly for the prize to be split between Becquerel and Perry. But Perry insisted to influential people on the Nobel Committee that Marie had originated that research, conceived experiments, and generated theories about the nature of radioactivity. Both Curies shared the Nobel Prize in Physics with Becquerel in 1903. It was the first Nobel to be awarded to a woman. Let us stop here. We will continue our conversation in our next video, part 2. Please like the video, subscribe it, and share it with friends. Thanks for watching the video.